Welcome. This is a short video on how to set up gravity simulation for your marble climber. A couple things to look at quick before we go into the simulation environment is that when you build this assembly in general, the first thing you want to bring in is the base, and make sure you ground that. That's that little pin symbol. You can right click on an object and right there's grounded. So the base should be the only grounded part in our assembly. All the block shapes are with just typical mate assemblies. They're all constrained and locked fully into position. We use work planes a lot on the dowels and the cams to make sure that they're all spinning together. And as far as the pistons go, you want to make sure that you have a tangent constraint between the cam and the bottom of the piston. And let me just rotate that a bit to show you. So that's kind of an important setup as far as that goes. The only other, each piston has several constraints because it had to be locked into place against an opening, the side of the opening, another piston, and then I turned the work planes on actually in the center of every cam, so it was very easy to put along the center of every piston. And just one way to look lock that down. But again, tangent's the main constraint between the cam and the piston. And you want your marble positioned pretty much right here, so it's above this area. Actually, we may move it a little bit closer to that bowl shape. Let's look at here. Yep, that looks good. And with that all ready to go, I should be able to grab the handle and things move. That's a really good sign that hopefully it was put together correctly. No rotational constraints of any kind here. Everything so far is all mates or the tangent constraints. So with that little review, let's move on to environments. And dynamic simulation is what we're after. And you can say no to the tutorial. So I'm going to hit F6 to go back to my default 3D view. And this little player window that pops up, we pretty much have to live with that being on. Anytime we hit play and run a simulation, we have to use it to get back out of the simulation mode so we can do tweaks and edits here. And the first thing you'll have to do is go down to your gravity, and it's under external loads. You may have to expand it. We're going to double click gravity, and you're just going to choose really any edge on the object or on the assembly. I just happen to use this little vertical edge of the base right there, just the edge. And my arrow came in defaulting down. I could toggle it up or up, but gravity usually works in the down direction. And we just hit OK. And gravity's been set now in this environment. That being said, if things are working correctly, you should have the pistons all under the mobile group, and the welded group should be your crank and your end cams, or the circles we have on each end and that dowel through the middle. And if you want to try to hit play right now, you're welcome to. And you should see that things disappear. They just fall through, and the environment is infinitely big, so they're still falling, but we don't need to think about that anymore. So stop on the player, rewind back to 0, and then here's this little button, construction mode. You have to click this to make the gray go away on the side, and that way we can modify things here. And the big thing we have to do is we got to create contact between parts so the computer knows there would be a physical interaction between several objects. Not all the constraints that we set up in the assembly carry over. In fact, that's kind of why that one tangent constraint was important. It doesn't carry in, and that's part of getting good motion here. So in order to do that, it's inserting a joint. And we're going to go with 3D contact. and we're going to say that this piston, and it doesn't, from what I've gathered over the years, it doesn't really matter where you click, but I guess it makes sense to maybe click the bottom of the piston and the face of the cylinder or the cam and click apply. I'm going to cancel this just to make sure it's going to do what I want. F6, back to 3D view, and if I hit play now, there we go. We see that that piston is stuck now on top of that cam. And actually, I've turned on a motion mechanism to make this dowel spin on its own, and I'll look for that in a little bit to tell you what it was. But as long as it's sitting on top of the cam, we're off to a great start. Stop the simulation, rewind it, construction mode, and I'm not clicking super fast here because I want to crash my computer. So back to insert joint, 3D contact, and I'm just going to finish putting these on. So I'm on the second piston, second cam, apply, third piston, third cam, apply, fourth piston, apply, and fifth piston, fifth cam, apply. And cancel, F6, let's hit play. Boom. All the pistons are staying on top of the cams. That's awesome. So stop, rewind, construction mode, because if you noticed, then on mine or on your screen, the marble is still falling away into nothing. So now it's the marble's turn. Okay, while we're in construction mode, one of the first joints you need to put in for the marble is actually called now a spatial joint. I'm just going to click the marble, and usually I just say component 2 here, and just usually like the corner of my base, and apply. And my best explanation for that is that because a base is kind of a stationary object, this just helps the computer, calculate spatial relationships as it's moving everywhere with something that's a constant, like a zero if you want to call it that. Once we have that, we can start putting in all of our other contacts the marble will have. This one takes a little bit more thought because you have to think about everything the marble would touch. So it'll be marble and bowl. And when I click this bowl shape, that really means the whole part that this bowl is really in. Apply, be marble, and first piston, apply, marble, second piston, apply, marble, third piston, apply, marble, fourth piston, apply, marble, fifth piston with a ramp, apply. And I have to remember it could roll up and hit that back wall, so marble, back wall, apply, marble, ramp, apply, marble, back wall with a curve here, apply, marble. This one I've missed myself a few times because technically this curve is part of the upper block. This end, the top of the end needs to be a contact. Apply, and marble, and this little sidewall here. Apply, cancel, and F6, and play for simulation. And if you don't have the driven constraint on yet, you can always grab the handle and try to slowly crank it yourself to see what happens. Let's just see if we can get this to simulate through one piston, and we're not going to watch it all run. If yours isn't simulating very long, in the player window here, you can change your number of seconds. You can see I have mine bumped up to 20 now. I forget what it defaults to at the moment. It might be 1 second. Change it to a higher number so that way it runs. And as you can see, my marble is being lifted up the pistons, and it generates super slow the first time. Once I'd let it run all the way to 20 and then rerun it, it works faster. But looking good so far. Stop. Rewind. Construction mode. You can see these windows are not, gray anymore, so we can actually modify some things. All right, so final step. Once you have added all of your joints and you hit play, and you can see that the marble and all the pistons are staying in position like they should be, and looks like yours might just wiggle a little bit as gravity kind of just settles out a bit. We at least know we can have the basics there. We need to imply a motion, so that way it's like there's a little motor running the crank handle for you. And to do that, we're going to go into look at the standard joints, and hopefully you guys see one that says revolution already in there for you. And that was just built because of how you constrain things. Double click it, and probably start on the general tab. Click the DOF1 tab. That stands for degrees of freedom, which is a movement thing. And we're actually going to go to the last button, which means edit and imposed motion. I think it was already checked on mine actually, because that's where I was just checking something out. So we'll go here, we're going to check the box to enable a motion, and we're going to use a velocity. That way it's a constant. And we went with something a little kind of fast here, 60 degrees a second. It's a good starting point. You may find a little faster, a little slower, or something that you prefer, but that's what I recommend starting with. Click OK, and that should essentially be the motor that tries to spin the handle for you. Again, make sure you get like 20 seconds, maybe 30 seconds there. See what happens. Click run or play on the simulation and sit back and let it go for a bit, because the first time you go through this will take a couple minutes probably for it to process. And hopefully you see something working when you're done. I know that sometimes friction behaves a little differently than what it normally would. This is something we haven't dabbled in with much yet, but as long as we're kind of simulating some basic gravity and motion, it's a great first step, I think, to seeing how a real part might actually behave just through computer simulation first before you ever build it. So good luck. Hopefully it all works out. And ask any questions as needed, please.